private well water maintenance, private well water treatment, and I'll provide you with a couple of resource web links at the end as well. So in Connecticut, about 23% of our state's population are supplied by their own private residential wells. That equates to over 820,000 Connecticut residents. The areas shaded in the bluish gray on this map show the areas that are served by regulated public water systems. Even though, as you can see, that geographically there's a lot of landmass not served by public water, the shaded areas or areas that are served trend towards areas of higher density population and kind of straddle our main highway corridors. But still, geographically, that leaves a lot of us that fall into those unserved areas, including myself, and so we rely on private wells. Private wells are not regulated water systems, as you probably know. Well locations and permits, however, must be approved before construction of a new private well, and newly constructed wells must also be approved for use after they're installed, and that does require testing. But after that, there are generally no testing requirements moving forward for private well users. The Safe Drinking Water Act only applies to public water systems that serve a minimum of 60 or 25 people or more for at least 60 days a year. So that leaves a lot of private well users to be responsible for testing their own water quality and for maintaining their own well water systems. When you think about the associated costs, think of it as a kind of a trade-off for those that are on public water systems who actually are paying for their water distribution. So what does our Connecticut Department of Public Health private well program actually do? I'm currently the only full-time dedicated staff person at DPH for private wells, but I try to make an impact anytime I can, and I'm very thankful for opportunities like this one to reach out to private well users throughout the state. The main goal is to empower private well users with the information they need to make good, informed decisions about their well water supplies, and hopefully ultimately help them reduce their risk associated with the use of untested water. Having said that, why is testing our private well water so important? Most importantly, it helps us ensure that the water that you and your families are using every day is safe. It's a pretty obvious one. It obviously can help us identify water quality problems. So if you do find a problem, you can do something about it and be informed about that as well. And for some of you, if you have a treatment system already installed, testing can help you determine whether or not that treatment system is working properly, and actually give you a before and after snapshot of what's going on with your groundwater today. And lastly, and it's very important to keep this in mind, when you test your water quality, think of it as a snapshot in time. Water quality can and does change, so testing on a routine basis is highly recommended. All right, so this is what our hard copy guidance document on private well testing looks like. Generally, when I do this presentation, I hand people copies of it. Unfortunately, tonight we can't do that under the current circumstances. But this is available online. It just doesn't have the pretty pictures and colors on it. So, and I'll give you that information on where you can find that a little bit later on. But I'll be using this recommended test table from the document as an outline during the next several slides. Before I move forward, however, I want to mention that this list is not all inclusive. So recommendations provided here take into account a number of factors that make up these recommendations for all Connecticut private well users. But again, it's not all inclusive. It can't really cover every single test that you could do out there. All right. So the very first test listed on this table is the basic indicators test, which is actually not a single test, but rather a series of them. So this slide might take me a little bit longer to get through than the rest. Basic indicators mimics the minimal test required for newly constructed private wells. So if you had just installed a well, this is the minimum required testing that would be asked for in order for the local health department to approve the use of that well. And if you've tested your water quality in the past, not just aside from that newly constructed test, but if you've tested at any other point, there's a good chance that this is the panel test that was performed or close to it. We recommend that the basic indicators test be done on an annual basis or every single year. The basic indicator test is broken down into its own table, and that's what you're seeing here. Total coliform is shown first, and is a bacteria, total coliform bacteria. For many, total coliform bacteria itself is not necessarily harmful to our health, but instead it's used as a quick and easy way to let us know if something is getting into our well water that shouldn't be there. So we shouldn't see any bacteria in our well water naturally. If it's present, that means that there's a pathway. So it's used as an indicator organism. If your water sample tests positive for total coliform bacteria, the lab will automatically test for E. coli bacteria, which could pose more of an acute health risk. The acceptable limits for both total coliform and E. coli bacteria is 0. So if your water tests positive for bacteria, you should further investigate the probable source. Like I mentioned before, it usually means that there's a pathway. So you might want to look to see where that bacteria is getting in. It could be a well cap that isn't secured properly, or maybe you just had some plumbing work done where something was introduced during that time. Basically, try to identify the pathway of the bacteria. Then it would be recommended that you correct any suspected culprit and then disinfect your well and water system. Moving down the list, nitrate and nitrite are two parameters that also pose an acute health risk for many, especially to infants, pregnant women, and the elderly. Consumption of high nitrates can lead to a lack of oxygen in the blood and cause blue baby syndrome. Nitrates are naturally occurring in soil, generally, from decaying plant and animal matter. However, at higher levels, it usually indicates that there's a pollutant source. Sources could include things like agricultural lands, over-fertilization, manure or pet waste, septic waste, leaking sewers, and even compost. If you have high nitrates or nitrites in your water, there are treatment options that are available, like reverse osmosis or anion exchange, that can reduce those levels. But again, it would be wise to try to find the pollutant source and help mitigate that if possible, so that you can prevent further pollution associated with the nitrates. The rest of the parameters listed tell us about the general makeup of our water. pH can tell you whether your water is acidic, neutral, or basic. Odor is very non-specific, but it just indicates whether or not there's something in your water that is imparting an odor. Sodium and chloride are both naturally occurring in groundwater, but when found at higher levels in water, can usually indicate that there may be a potential pollution source there. Hardness represents the amount of mineral content in your water, specifically calcium and magnesium. And the hardness ranges will tell you whether your water is soft, and soft water can be in the range between 0 to 60 milligrams per liter, or hard, which is a range of 121 to 180. And then you have anything over that would be very hard water, which a lot of folks in Connecticut fall under. The apparent color is again non-specific, like odor, but can just indicate whether or not there's something in your water that's making it discolored. Sulfates are naturally occurring and can often impart an odor or a scale in your water and your fixtures. Turbidity, again, is one of those that is non-specific, and it's kind of like the cloudiness of your water. And the next two are iron and manganese. So a lot of times when folks have high iron and manganese, the turbidity might also be high because of that. So the last two, as I mentioned, are iron or manganese. And unfortunately, there are two that many in Connecticut experience. Iron often causes discolored water that can stain fixtures and clothing and can impart an unpleasant taste. Although there's no known health risk associated with iron in your water, it certainly can be a nuisance and is often very problematic for a lot of homeowners. Manganese in water is similar to iron in that it's nuisance-like. It can stain fixtures and your clothing, and it sometimes will impart an unpleasant taste in your water as well. But unlike iron, Manganese at higher levels may be harmful to our nervous systems. So there are actually two standards for manganese. One that is an aesthetic-based level at 0.05 milligrams per liter, and the second of 0.3 milligrams per liter, which is a health-based level. All right. So following along that list at the beginning, next up is lead. I'm sure everyone has heard of lead as it makes its way into the media spotlight often. We recommend that everyone test their water for lead at least once while they're in their homes, but ideally you would do it every 3 to 5 years, especially when there are young children or pregnant women in the home. Health effects associated with lead are various and include risk impact to the brain, kidneys, nervous system, red blood cells, and blood pressure. The severity of these health effects depends on the concentration of lead that the individual is exposed to and their developmental stage at the time of exposure. Unfortunately, because of that, we know that lead exposure to children can have more severe consequences. Lead in groundwater is not naturally occurring generally, but rather it comes from our own home's plumbing system. This includes all parts of a plumbing system, starting at the well right down to the faucet that your water comes out of. For these reasons, we recommend that when you test your water for lead, that 2 samples actually be collected. The first is called the first draw sample. It would be collected after your water in your home hasn't been used for at least 6 hours, kind of giving you a worst case scenario. Usually first thing in the morning is a good time to grab that sample. And the second sample is a flush sample. So that would be collected about 5 minutes after you let the water run. And this gives you more of an indication of the lead levels during normal operating conditions within your home. So after the water's been running a little bit. Sorry. So it should also be mentioned that the more corrosive your water is, the more likely that lead would actually leach from your plumbing. So a lot of us in Connecticut have older homes or older plumbing. Just because there's lead in your plumbing doesn't necessarily mean that it would actually leach into your water. But if your water is corrosive, you have more of a chance for that to happen. So some of the corrosivity factors that might play into that are things like a low pH, if you have a very soft water, high concentration of chlorides, and there are many other factors that come into play there as well. If you find that you have lead in your water, there are different steps that you might want to consider. One is to look at whether or not replacing certain plumbing in the home is an option. That's not always a viable solution for a lot of folks. The second and probably more common one for people to do is to look at whether or not they have a corrosivity factor that's playing into that lead level and actually resolving that. If you have a low pH, bringing it more to a neutral level. And if all else fails there too, installation of something like a reverse osmosis at your kitchen sink can also provide some protection from the lead itself. All right, so next up is a set of 3, arsenic, uranium, and radon. We recommend that everybody test their water for arsenic, uranium, and radon at least once while they're in their homes, but again, ideally, at least every 5 years. The potential health effects associated with each are different for each parameter. For arsenic, they vary and include a risk impact to our skin, cardiovascular, immune, and neurological systems. And they may also increase our risk for bladder, lung, liver, and skin cancers. It's a pretty long list, unfortunately. For uranium, the potential health effects or risk is for lung cancer, and there is some evidence that radon at higher levels may increase risk for stomach cancer as well. All 3 of these, arsenic, uranium, and radon, are naturally occurring in our groundwater. So it's not something that's put there or man-made, it's just unfortunately naturally present in Connecticut's bedrock and environment. In some cases, arsenic can also be associated with some industrial or agricultural uses. And when we think about agricultural use, it's primarily old apple orchards. I also want to mention that radon is actually a radioactive decay product of uranium. So uranium is the parent product, which decays into several daughter products, of which radon is one of. However, if you have one, it doesn't necessarily mean that you'll find both in your water, but it's always a good idea to test for both. I also want to mention that the primary concern with uranium is with the chemical properties in the water and ingesting it. So it's the water that you're consuming during the drinking and cooking. And this is the same for arsenic. However, radon is the complete opposite because it's a gas. So concern is primarily with water being used during bathing and showering or other activities where the radon can off-gas. So when you're looking for treatment options for uranium and arsenic, many folks can consider using a point-of-use treatment system, something like a reverse osmosis or a metal oxide filter for uranium. That could be installed just right at the kitchen sink. But for radon, you would want to consider a whole house treatment for the reduction of radon in your water so that it doesn't off-gas as you're using the water. I wanted to go a little bit further into arsenic and uranium specifically because in 2013, our department actually started an arsenic and uranium study. Some of you may have actually come in to get free bottles from us during that time. We offered the free arsenic and uranium testing to private well users throughout the entire state for about 5 years, wherever private wells are prevalent. Free testing ended at the close of 2018. And then during that time, we actually worked with the United States Geological Survey to map and evaluate the data that we had about halfway through that process. The United States Geological Survey is now mapping and evaluating all the data which we have, which is over 2,000 points for both arsenic and uranium each. Which is going to provide us with a much more refined and accurate grid-based account for arsenic and uranium throughout the state, wherever private wells are prevalent. The only areas that we didn't collect water samples or private well samples would be the areas where there are no private wells, you know, the Hartford or Bridgeport, the cities where you wouldn't find private wells at all. This new mapping is expected to be released sometime in the next few months. So keep an eye out for that if it's something that you're interested in looking at that analysis a little bit further. In the meantime, this is what we actually have available. And like I mentioned, this was about halfway through the process. I'm excited to see the new mapping efforts because they're just going to be a lot more refined and provide us with a more concise look at and comprehensive look at the state. All right, continuing down the list is volatile organic compounds, which are commonly referred to as VOCs. VOCs are actually a variety of man-made chemicals, and so when testing for VOCs, you would be testing for a whole panel of related chemicals. It's recommended that everybody test for VOCs at least once, but more often if a problem is suspected or identified. So, you know, if you have a home heating fuel tank and that leaks or has a problem, that would be something where you would want to test for VOCs. Potential health effects vary depending on each specific compound. So some may have short-term and some may have long-term adverse health effects. And some compounds may increase your risk for certain cancers. VOC sources include gasolines, fuel, solvents, industrial chemicals, and paint thinners. They're also widely used as ingredients for a lot of our household products like paint, varnish, wax, cleaning products, and even more in some cases. If you were to identify having an issue with VOCs, there are treatment options available. Most commonly for most VOCs, a granular activated carbon treatment system would be installed for the whole house to treat all the water in the house as it moves through. So that would be one treatment option that could be viable. And our final recommended test is fluoride. It's recommended that you test for fluoride every 5 years when you have children under the age of 12 in your home. Potential health effects are primarily primarily to the teeth and bones, but they can also have both a positive effect on our teeth and bones or a negative effect, depending on how much fluoride is there. So too much fluoride can lead to a condition called fluorosis, and it can have a negative health effects to us. Fluoride is naturally occurring in our bedrock and our environment, so that's why it's important to test for it. It's not commonly found at higher levels in state in Connecticut, but there are some areas where it has been found to be in higher levels. So it's always a good idea to test, especially, like I said, if you have younger kids in the house. Your dentist or your doctor may be interested in what level the fluoride is at. All right, and as I mentioned at the beginning of the table, is that this list is not all-inclusive. So there could be other contaminants that you want to test for. Those additional tests may be, advisable on a case-by-case basis. So you want to consider what other things you're around. The list that I just discussed was really looked at as general testing for everybody that would recommend. And it's based on a whole set of factors. But maybe if you live near agricultural lands or something like that, you might want to test for pesticides as well. And then there's emerging contaminants. People probably have heard PFAS in the news recently, which is an emerging contaminant. So depending on where you are and where your property is located in, you may want to consider doing additional testing based on a case by case. One thing to consider though is that the laboratory that you're going to be working with may have individual lab capabilities, and they may not be able to test for all the different things that you're looking for. So you may have to kind of shop around or work on looking at out-of-state laboratories as well, depending on what you're trying to test for. All right, so understanding where your contaminants are coming from. This is pretty self-explanatory. Some are naturally occurring and some are man-made. So when you're looking at that, you want to consider your surrounding land use. Sometimes you can talk to your local health departments who know your area better. Talk to your neighbors to see what's going on in their home water systems. But like I mentioned before, surrounding land use, looking at both the past and present use to determine whether or not you should be testing for certain things. I mentioned pesticides earlier. Sometimes people will buy property that was formerly agricultural lands. You might want to test for pesticides based on the past land use. And you also want to consider the local geology in your area. Like I mentioned before, arsenic, uranium, radon, fluoride, those are all naturally occurring things that can be in the bedrock. So the geology will play into that as well. So moving on to interpreting your private well test results. And so some of this can get kind of crazy because there's so many different sets of standards. Before I get into that, I'm going to say that if someone has questions about their private well test results, you can always contact me. Right now, because of the way that we're operating, I'm working from home. Email is the best way. So if someone wanted help to understand their test results, if they have test results, they can always get in touch with me, and I'm always happy to help evaluate and help you interpret what all the test results mean. But there are different standards. The first two listed here, maximum contaminant level, or MCL, and action level, AL, generally refer to a risk to health. So those are things that we want to prioritize. So if there's a health risk, we want to make sure that we're protecting our health. Guidance levels are kind of varying. Sometimes it could mean a risk to health, and sometimes it can be more of a nuisance type issue. Radon, for instance, is actually a guidance level in Connecticut at 5,000 picocuries per liter. It is not an enforceable number, but it's a guidance level that has a health risk associated to it. And the last one listed is the secondary maximum contaminant level, or SMCL. And those are always going to be based on nuisance-like issues. Usually they're going to be the ones that are associated with a risk to your plumbing, maybe some kind of corrosivity factor that can strip your plumbing or clog your plumbing, add a scale inside the plumbing itself, risk for staining both your fixtures and your glassware and your clothing, and they may impart an unpleasant taste and odor to your water as well, and a color as well. So this next slide is actually just a breakdown of all the different contaminants and parameters that we talked about, that I talked about earlier. I wanted to have one general slide so everybody could see the different standards associated for each one. And as you can see, some of the parameters actually have multiple standards associated with it. In some cases, like the MCL and the action level are actually the same. In other cases, you might see them varying. So for instance, manganese and lead both have an action level, but no MCL. And manganese is definitely an outlier where it has both an action level and an SMCL for nuisance-like issues. So this is a good slide as just a reference point for folks if you have private well tests that you want to compare these numbers to. This next slide is again just a snapshot of that document that I mentioned before that I was kind of following along with the private well testing. This can be found on our two websites listed here, and I'll reiterate those at the end of the presentation as well. And moving on, we'll talk a little bit about well water system maintenance, because it's important for us to consider maintaining our water systems. A well-maintained well and water system can help make our water less vulnerable to contamination. So that's a very important piece of what we talk about. Remember that well pumps, storage tanks, treatment devices, plumbing, well caps, hot water heaters, all of these are going to need attention at some point. So make sure you give it the attention that they need. And always remember that unfortunately there is cost associated with that. And so you want to kind of be prepared for those associated costs. And it's always better to be preventative rather than being reactive after a problem has happened, if possible. So this guidance document is the Private Well Water Systems in Connecticut Best Management Practice Checklist. And I often hand this out to homeowners or provide it to homeowners. A lot of times if they're maybe buying a home for the first time where there's a private well, so they have kind of a checklist to see what they should and shouldn't be doing around their wells. There's things like keeping the area around your well accessible, limiting the activities around your well to the over fertilization of those around your well, the use of pesticides and herbicides. Another big one too that comes up a lot is in the wintertime in Connecticut, making sure that you're not over applying salt, melting salts too close to your wells. So those are a couple of things to consider. I also recommend that annually people inspect their well casing to look for any vulnerabilities there. Is the well casing in good shape? Is the well cap in good shape? Is it secured tightly to the wellhead itself? Another important thing too is you want to make sure that the well the soil around the well is actually pitched away from it. And I'll show you a better slide here. So this is kind of a close-up of the well. On the left-hand side of this is just a schematic of what a well is required to be drilled and constructed to look like today. If you have an older well, the construction standards were a little bit different prior to 1971, so it may not look like this, but it can always be upgraded to look like this, so something to keep in mind. So as I mentioned, you want to make sure that the well cap has a good secure seal, has a rubber gasket, it's bolted against the actual casing itself. There is, in today's construction, there are usually a pitless adapter that allows you to run the water line below the frost line underground. And this way it also allows you to bring the wellhead above grade and give it more protection. In the middle there, you actually see what a well cap, a proper well cap will look like, both the top side and the underside. On the underside, I've actually circled there in red where the well vent is, and that's if for some reason your well needs to call for air because of a pressure issue. It could actually suck in air if it's needed, and it is also protected. So it's a nice fine mesh screen there that'll protect the anything from getting inside that well. And over to the right, you see that this is just a general schematic of what a lot of our well water systems look like. You have your general well, and it gets plumbed inside your house. It usually goes to a storage tank. If you have treatment systems, it might go through that, and then it gets distributed through your house. So it's pretty basic. In the next slide, you'll see some of those things that I mentioned before when I talked about vulnerability. It's pretty obvious to see some of the concerns here. In some of these pictures, the two that are closer to the top, one is a drilled well and one is a dug well. You can see in both of those pictures that there are vulnerabilities right at the well cap itself. They both have spaces, they're not secured. So that could allow for anything really to get inside your well. Debris, insects, in some cases, rodents, and that certainly can have some negative consequences to your water system. The two on the bottom, the one on the left there, is a well and a well pit. So a lot of us that have older wells on our properties, generally that were drilled maybe in the 50s and 60s, might look like this, where the well itself is located in a well pit. And that was so they could bring the water line below the frost line into the house, and because the pitless adapters weren't readily available back then. But in this case, what you can see is that those black lines that are going inside the house, you can't see the well cap, it's underneath that, but it's submerged in water that's just standing there. So that is a big vulnerability and could be a potential pathway for, like I mentioned before, something to get inside the well that shouldn't be there. And then the last picture over to the right shows where a well casing has deteriorated. And there's a hole there. Now that doesn't happen that often because these are steel casings, but under the right conditions and circumstances, that can happen and did, and certainly can have negative consequences to your well and water system. So I'm going to move on to what options are available when water quality issue is identified. So you can look at alternate sources. Bottled water is oftentimes something that people might use as an interim measure until they figure out what their next step is going to be. Alternate sources can also mean utilizing a new source when one's available, and that could mean drilling a new well, but that's only when it's practical, and you may not, you want to make sure that you're not going to drill a new well and have the same problem. Or connect to a public water supply, which many of us don't have the availability to do, or in many cases, the funding to do. You can also look at removing or mitigating the contaminant source, depending on what that type is. So something like I mentioned before, like the nitrates or maybe a bacteria, trying to find out what the source is and mitigating that and removing it to hopefully get rid of that problem. And then the last one listed is treatment. And this is going to be the option that's most viable for most of us when we're talking about water quality issues. There are many treatment options available. The type and size that you're going to use are going to be dependent on the contaminant that needs to be treated for and the level at which it's present. There is unfortunately no single water treatment option that can provide protection against all water quality issues. So it is possible to need more than one treatment option, especially when multiple water quality issues are discovered. The other thing too to keep in mind is that if you do find a water quality issue, your treatment contractor will probably have to work with you, and if they may want to look at other water quality parameters to see whether or not other things need to be addressed to properly reduce or remove whatever contaminant you're trying to get rid of. So when we're thinking about water treatment, you want to think about whether or not you need a whole house treatment system or a point of use treatment system. So does all the water in the house need to be treated, or could it just be the water that you're consuming or that you're drinking and cooking with? As I mentioned before, the primary concern with some contaminants like arsenic and uranium is with the water that you're actually consuming. So in some cases, you could look at installation of a point of use treatment system where you would install it at your kitchen tap, because that's where you're going to be getting your water to drink and cook with. And you could install that treatment system to treat the water that you're going to use for those purposes. But then for other reasons, for other treatment or other parameters, you might want to consider a whole house treatment, especially for something like radon or VOCs, where you want to remove it from all of the water so they don't off-gas as you're using the water in the house. So you want to think about that on a case-by-case basis. And the level at which those contaminants are present is also something you want to consider when you're making this decision. So this is just a schematic of different treatment types. These are some drawings I put together. I'll mention a few of them that are more common. Down in the left-hand corner is reverse osmosis. This is the one that I mentioned quite a few times. This is going to be installed. Sorry about that. This can actually be installed, or generally is installed under the kitchen sink or as a point of use. It can be installed whole house, but many times that is not practical for most people or viable, because there are some limitations with it in terms of how much water it requires to do its job, and also with the cost associated with it. It can be very costly as a whole house option. However, reverse osmosis installed under your kitchen sink can be a very good solution, and usually one that is more practical and affordable for most homeowners. On the bottom right-hand corner, you see ion exchange. Most people will refer to these as water softeners. A water softener is a type of ion exchange. It's a cation exchange, and there's also an anion exchange. So depending on what you're trying to remove from your water, is what's going to determine which one you're going to use, cation or anion. For arsenic and uranium, you could use an anion exchange. For hardness or iron and manganese, you could use a cation exchange. So those are a few things, a couple more things there. Granular activated carbon can be installed both as a whole house treatment, or it can be installed at your kitchen sink as well. And a lot of times people use like a Brita or a pure filter. Those are usually carbon black, and we'll just do, you can use those as a pitcher filter. So a lot of people might have those in their homes as well. So when we talk about private well treatment, we do get a lot of phone calls and a lot of questions about how to maneuver getting a treatment system and what are the best things. How do I do this the right way? The questions we usually get are, which is the best option for me? I have multiple quotes and I'm not sure which one to choose. What questions should I ask my contractor? What are the system's maintenance and operation needs? What are the pros and cons of it? Does the treatment system backwash? That's an important one. And how do I properly dispose of the backwash water? Also very important. And lastly, how can I find a well water treatment professional? Those are all questions that we get a lot of. We do have a guidance document up on our website as well. It's called Private Well Water Treatment. It's just a quick 2-page document that helps answer a lot of those questions. Associated with that too, we also have a publication about questions to ask when purchasing water treatment equipment for your home. So it's actually a longer document. It's about 6 pages long, but it gives you some reference materials and questions that you can ask your contractor. In terms of the last 2 questions, if the treatment system backwashes, you want to make sure that you're properly disposing of the backwash wastewater appropriately. So there's technical standards that are managed by the Department of Public Health that dictate how that can actually be done. And you want to make sure that you are doing that in accordance with the technical standards, especially if you have a septic system on your property. Because many treatment devices, like a water softener cannot get disposed of. The backwash water can't be disposed of into your septic system. So you want to make sure that you're paying attention to that. And your local health department can be a part of that decision and conversation, or you can always call me and I can help you with that as well. And in terms of finding a well water treatment professional, that guidance document up in the corner there that I mentioned does provide some helpful resources on the second page that might be helpful. Obviously, you can do internet searches or word of mouth for your neighbors. But a couple of things I definitely want to tell people is make sure you check referrals, check for proper licenses. And also, when you're looking to install treatment, it's always a good idea to get multiple quotes. Unless there's someone that you're already working with that you're very content with, I usually recommend that, getting several quotes, getting maybe three quotes is a good idea. All right, and so moving on, this is actually going to be my last slide here. And again, this is just going to reiterate some of the resources that I mentioned, those two websites that I mentioned. The very first one on the top there is our main Connecticut Department of Public Health private well page. This one has a lot more comprehensive information, so there's a lot of stuff there. We're also unfortunately stuck with our formatting for the department, which is not necessarily a bad thing, but sometimes can be a little bit more cumbersome for people to search and navigate. So what we did is a few years ago, we actually had some CDC funding that allowed us to do a media campaign to try to reach out to more private well users. And so we actually put together a landing page, and it's testyourwell.ct.gov. And that landing page, what it allowed us to do is have kind of more of a catchy phrase that people would remember and can find our website and information a little bit faster. It's also a lot more streamlined. So there's only the streamlined, targeted information available there. You can get to our main page from that testyourwell.ct.gov page, but it's a great place to start if you're looking for general information. And I just wanted to mention what's there. On the bottom, if you can see on the bottom right-hand corner of the screen is a snapshot of what it looks like. There are 4 icons on the bottom. The first one says what to test for. That's the information that I provided at the beginning of these slides. So it gives you the information you need to find the parameters for what we would recommend testing for. The second green icon at the bottom is how to test your well. And that actually provides you with a list of the laboratories that can test drinking water in the state of Connecticut. The third one there says what to do if you have a problem. That is a link to the helpful resources and treatment information that I mentioned just now. And the last one is how to protect your well. And that is the guidance document on best management practices for your well and water system. So that concludes my slides. This is my contact information. Normally I have my phone number a lot bigger in this slide, but because of the way they're operating right now, my email is probably the easiest way to get in touch with me. I'm always happy to answer questions. I'd be happy to answer questions now if that's okay with Jean, if she has any. Otherwise, please feel free to email me at tiziana.shea@ct.gov. And check out both of our websites. Like I said, the landing page is an easy one, and I usually direct people to first, testyourwell.ct.gov. And that ends my slides.